Hi everyone. Today we're going to study higher derivative. Suppose that you have a function, say f of x. Then the derivative would be f prime of x. We can consider f prime of x as a new function and find its derivative also. That is finding d over dx of f prime of x. This symbol here can be simplified into this symbol, and we read this as f double prime of x. And this is now considered to be the second derivative. We can show also that the second derivative is d over dx of d over dx of f of x. And simplifying this, we may show that d square over dx square of f of x. Or if the function is given as y, this is one of the most popular notation for second derivative. And this is d square y all over dx square. Using the second derivative of f, we can find the third derivative, the fourth derivative, and so on. Successive derivatives can be denoted as follows. Given the function f of x, f prime of x equals d over dx of f of x. This is the first derivative. F double prime of x is equal to d over dx of d over dx of f of x. Simplifying this, we can write d square all over dx square of f of x. And this notation is for the second derivative. We have now f triple prime of x. And this is equal to the derivative of the second derivative. So we see here, we have d over dx of d square over dx square of f of x. We simplify this into d cube all over dx cube of f of x. This is the third derivative. In general, we write f raised to a power n inside a parenthesis of x is equal to d with power n all over dx raised to power n of f of x. And this is the nth derivative. Let us see this example 1. Find y triple prime of y equals 2x raised to 4 minus 3x plus 7. The y triple prime here means the third derivative. For our solution, let us begin with the first derivative. So y prime equals this 4 multiplied by 2 becomes 8 multiplied by x with the power 4 minus 1. So we see here power 3. So 8x cubed. minus the derivative of 3x is here 3, so minus 3, plus derivative of the constant 7 is 0, so we will not write anymore. Therefore, the first derivative is equal to 8x cubed minus 3. Next, for the second derivative, that is y double prime equals this 3 multiplied by 8 becomes 24 times x raised to the power 3 minus 1. So we see here 2. So y double prime is equal to 24x squared. The derivative of the constant is 0, so we will not write anymore. For the third derivative, that is the y triple prime is equal to this power 2 multiplied by 24, it becomes 48 times x raised to the power 2 minus 1. So we simply put here x. So y triple prime is equal to 48x. This is our final answer. Let us see example 2. Find d square y over dx squared. So this is about second derivative of the function y equals x raised to 5 at the point x equals 2. Let's begin with finding the first derivative. So we have dy over dx equals the power 5 comes down here as coefficient. So we have here 5x raised to the power 5 minus 1, which is 4. So the first derivative is equal to 5x raised to 4. For the second derivative, we will have now this symbol. So we have 4 times 5 is equal to 20 times x raised to the power 4 minus 1. So we have here 3. So the second derivative is 20x cubed. For our problem here, we can write this in symbol as d squared over dx squared of the function x raised to 5. And we put a line here, and the subscript is that x equals 2. This is about the second derivative, and we are going to evaluate it when x is equal to 2. So this is equal to the second derivative value, 20x cubed. Now, let us substitute the value of x is equal to 2. So we have 20 times 2 raised to 3. And this 2 cubed will give us 8. And 8 times 20 is 160. This is our final answer. I hope you learned something from this video. See you again next time.